Let's do it. First part's the construction side of things. Alright. If you're really concerned about trajectories and all that sort of stuff, well, that we'll do in a moment. What you need to think about is, first of all, when you're constructing, is what it's going to cost you to do things. Think of your DeltaV as a currency. Alright? It's going to cost a certain amount of DeltaV to do X. Let's take a look at this. Right. At the moment we have 1023. The simple explanation of DeltaV is that it is the amount of potential energy that you've got to change your trajectory. So let me revert back to something that I used to revert to. This is Soda Shack. Soda Shack here has been my little teaching tool for quite some time. Imagine Soda Shack is your craft, right? And Soda Shack's traveling this way, right? Going this way, so just moving like that. If you use some DeltaV from here and fire your engines, it's going to propel you more that way, okay? It's measured in meters per second because it is your potential speed, right? But if you want to go that way, you can't fire your rocket that way if it's pointing that way. You've got to flip it over, and you've got to spend money. You've got to spend some DeltaV that way, and it will bring you back. It'll look like you are slowing your speed, but the reason why it looks like it's slowing the speed is because everything is circular. I can't put Soda Shack back now. You can sit over here. Everything is a circle. You're trying to get an orbit, and then once you're orbiting Kerbal, then you want to get further out and increase the size of that orbit to take it out to the moon, for example. It doesn't have to be an exact circle. It's a circular movement. Right? That's all it comes down to. You're just changing the dimensions of that circle based on your speed, based on your distance, and the efficiency at which you make those burns. Right? Ask questions. Absolutely. Root negative, go for it. That is exactly the point. Ask questions and I will give you more detail. Alright? So DeltaV is limited by your energy, and the change of trajectory is relative to celestial bodies. In a manner of speaking, yes. It is relative to your circular movement. Right? The gravity will always be there. The gravity is a constant. Right? You will always be affected by a certain amount of gravity around a celestial body. Right? So the DeltaV is how much potential energy you have. So let me give you an example. Alright? With this swivel engine, Reliant engine, we've got 1023 DeltaV. If we switch this over to this, we have 434 DeltaV. The reason why is because that engine is not very efficient. And we're firing in an atmosphere, it's not a very efficient engine in an atmosphere. However, if we were in orbit, that engine that we had at 1023 before becomes 1096, right? So it's just a slight increase. But if we grab this little guy that is efficient outside of an atmosphere, that 434 becomes 1760. It's quite a substantial difference, right? So different engines have different characteristics. Some are really good for atmosphere, some are really not, and you should use them in space. Nuke engine, prime example. Nuke engine. In an atmosphere, that's 172. Outside of an atmosphere, that's 745. 4 times the amount. At least 4 times the amount. That's crazy. That's crazy. DeltaV is limited by the amount of fuel you pack. That's absolutely true as well. And the type of engine. Correct. Just how many DeltaV and TWR should I have to make a manned moon lander? That's what we were trying to work out before, Frosco, and we'll do that shortly. My deck, I've got a space station going around Kerbal in a 126 kilometer orbit. For the past 4 hours, I've been trying to have an orbit around Minmus, take science there, and dock the station. However, I'm always missing fuel to circularize orbit around Kerbal and dock. Any tips? That's a really good one. I'll be honest with you, I don't know. More fuel is really the best thing. More fuel, that's all it comes down to. Alright. Alpha Blue, yes, you would know that. You would know that the different engines have different characteristics without Kerbal Engineer. However, you have to do the calculations manually to find out what sort of difference that is. You can look at a bunch of statistics, but what that translates to in DeltaV and thrust to weight and all of that makes a huge difference. Okay. So that's one part of it. All right. Second thing, if we bring it back to the compact version, reason why everyone uses the compact version is because you only really need to look at TWR and DeltaV. Right? The TWR is your thrust to weight ratio, right, as it stands right now. Now, this is non-atmospheric, so this is outside Kerbal, in orbit. With this nuke engine, you have a thrust to weight of 1.23. Think of it as a percentage, where 1 is 100%. So this is technically 123%. Now, what does that mean? What does that mean? That throwing a whole heap of numbers at you right now, right? 100% thrust to weight means that the amount of power that you have to lift that craft is exactly the same amount of power gravity currently has on that particular craft. So if you've got, say, this, all right, in atmosphere. So let's take it back. 0.61. That has 61% of the power required to lift it off the ground. There is more gravity. There is more gravity acting upon this craft than this engine is capable of producing to lift it off the ground. All right? That's really, really important to bear in mind. If we switch this over for the Reliant, that has a thrust to weight of 6.36. So that means it is 636% of the power coming out of that engine as the gravity is acting upon this particular craft. Okay? You can thrust limit that and bring the thrust down and adjust accordingly, all of that sort of stuff. The simple point I would make on TWR, well, there we go. So a TWR of 1 on Kerbal is equal to 9.8 meters per second. Sounds about right. Sounds 0.8. It sounds... Word vomit. So yeah, that sounds about right, actually. Missing manual volume. Really? That's a thing? Someone's actually got that? Hang on, I gotta say this. I'm gonna wait for that to load. Simple explanation is that in order for you to lift a craft off the ground, you need to be going more than 1.0 TWR. Now, if I were to lift this off, shoot this into space right now, it would just go straight up in the air, done. That'd probably make it about 300 meters per second in the air. That's about it. Excellent. That's a really good document there, Kerbal. Kerbal 007, that's a really good document. So Kerbal uses Earth relative values for physics. In a manner of speaking. For example, there is a mod called 64K, which scales up the planet Kerbal to a size comparable to Earth, if I remember correctly. Right? The scale of everything required is multiplied by 6.4. That's a simple way of explaining it. Now, With this, it is scaled down. The atmosphere is approximately the same, but yeah, it's not quite that simple. Now, what I will as a matter of fact, I will actually launch this craft with a TWR of 6.36. Actually, I'm going to put parachute on top. Where is the parachute? Is that under utility? It should be. Yeah, utility. There we go. All right, parachute. Says to launch. I'll show you. Now think about it this way, all right? As we sit right now, we're at 0 meters per second DeltaV. All right, we put our engines to full, we put our SAS on, and we have, we want vessel, bang, bang, bang. Okay, we take a look, DeltaV, 987 DeltaV is how much we've got available to us. Our mass, we've got 3,000 tons, 3 tons. Okay. Our TWR is 6.18. Engines are at full. Let's go. And let's revert flight. Oh, geez. I really wish that would stop auto staging like that. Let's put the engine and the parachute in the same stage, shall we? All right, cool. So, 6.18, bang, off we go. Look how fast that's going. The amount of G-forces would be insane. Insane. So we take a look. Now we were at 900 and something. That's completely spun out. Okay. Showing him the right way to Kerbal? Exactly. Staging mishap. Now if you take a look, look how high that's gotten us. Our Apo apps actually comes up here. It's just shy of 7,600. But we lost control because we just had too much power. And as this fuel ran out, this part got lighter. So it just lost balance and off it went. Okay? Now let's take it back again. Let's revert flight back to the launch. And let's grab this engine and let's bring it down. Let's make our thrust to weight 1.95. So 195% of the amount of power that's affecting Kerbal right now. Staging. Here we go. It goes up much slower. Much slower. Okay. Now take a look at how high we're getting to. There's 2. Remember we got to 7.5? I will get to that in a moment, Alpha Blue. I'll get to that in a moment to explain to you what I mean by that. Take a look at our TWR. It's increasing. We're at 1.95. We're at 1.95. That's increasing. 2.8 now. Why is that happening? Because even though we've limited the amount of thrust coming out of the engine, the craft's gotten lighter. And look, we're 14 kilometers in the air. We're considerably higher because we limited the amount of power output and made it last for longer. Okay? TWR increases as you get lighter. Exactly. Exactly. So, let's revert flight back to the vehicle assembly. Now, if we take a look, 6.17, what you can do while you're on the pad or in space or anything like that, or even in the VAB, you can go in here and limit the thrust. All right, that's 100% thrust of what that's capable of. If we take that down to 50 odd percent, that actually reduces our TWR to 3.15. Not bad. So if we take that down to say 1.76, that's about optimal. But think about how much weight we're actually losing. We're losing a heap of weight that takes us a long way up. So Let's take it down even further and say probably 1.36. We'll go like that. So reducing thrust gives you more control and a longer burn, but it doesn't increase DeltaV. Correct. Absolutely correct. That is good. Also avoids losses from drag in the atmosphere. Correct. Now, drag in an atmosphere, that's another side of things. Sup, Kazab? Because your weight is going down, you're going... Yep. Because you're burning fuel. That's exactly right. So some of your weight is disappearing as a result of that. Is there a way to determine the proper limiting value? Now, that is... It's an individual preference thing I've found, but as a general rule, it's pretty optimal to have it set at somewhere between 1.7 and 1.9. Alright? 1.8 seems to be pretty much spot on right in the middle, but it can be a variation either way. So that's pretty optimal. In a circumstance like this where the tank is so small, I would probably bring it down even further because that's going to be a huge weight change. That's going to be a massive change in the mass of this craft. So if we take it down to 1.36 right now, let's see. The max in brackets is the empty TWR. Sounds about right, Frosco. Sounds about right. So let's go here. There you go, root negative. I prefer 1.5 to 1.7. Yeah, I try to aim for 1.8. That's about what I aim for. Now, depending on your mission, your opinion may change based entirely on the mission at hand. Alright, now does that preference change based on the engine used? It can. I think it's more the mission that is probably your focus. If I'm going to Duna, I'm going to want a very different style of what I would be going for if I was landing on Minmus, for example. Here we go. See now, 7, 8. Now remember we were at 14 last time. Our Apoapse was going to be 14 kilometers. So our TWR is now up at 2.11. So 12. So we might be a little bit too low now. Maybe. Because it took a while for us to get to that point, and there was more aerodynamic pressure being put on the craft. That's what it comes down to. Okay. Let's go back. Let's go back to the vehicle assembly here. Let's go back to the vehicle assembly. Let's do some fun stuff. Let's go for... I like these guys. What do we got? Atmospheric. Get rid of the atmospheric. No, we want the moon. Now look at that. On the moon, TWR at 5.11. It's too much. Let's get rid of that. Get this. Get this. 6.9 with 1100 DeltaV. So plenty of DeltaV to get us back. So if we just limit that down, say to about... Because I'm leaving the moon, I want to actually leave it pretty well, so I'll stick it up just a little bit to 2. Right? We can make this into a moon lander quite easily. Here we go. Put something in orbit now. Show him how to build a rocket that goes to space and stays there. I'm going to do multiple parts here. Alright? We're going to make it real quick. Let's see. We want fuel. Let's see. Boom, 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 boom. We want radial decoupler. Is that probably the most appropriate part here? I think it probably is. Radial decoupler. Let's go for 2 of these. Running before we crawl. Not quite. Not quite. I'm going to cover multiple topics at once. You've heard of the phrase, killing 2 birds with 1 stone? Actually, as a matter of fact, probably a better option here is to look at the construction options we've got. Bring this here, pop that there, and we go for... What about a 909? Would a 909 be suitable here? There we go. 909. There's plenty of DeltaV in that. So that'd be enough for an orbital stage and to bring us down to the moon. That'd be alright. Let's grab some landing legs. That's aerodynamics. Utility. Thank you very much. Landing struts. 4 times symmetry. Okay. Is adding nose cones worth the aerodynamics to weight ratio? Yes. It is. Absolutely. Is it an efficiency build for the moon then? No, this is not an efficiency build. No way. Would leaving the moon's gravitational influence with a large engine be determined? Be detrimental, rather. With a large engine be detrimental? Potentially. With a large engine, the simple explanation I'll give you is that if you fire off in the wrong distance, it can alter your trajectory quite considerably with a large engine. Quite considerably. And we don't want to do that. Alright, even looking at this. Look at this. The TWR you've got up here, this is just wild. I'm keeping this high because I want to be able to get this craft into orbit. Alright, doesn't change the amount of potential that we've got in the tank. But we want to be able to... Oh, actually no, we're going to land with this as well, aren't we? It needs to come down quite a ways. Alright. Let's keep it up here and keep it up at 3 and adjust as necessary. Alright. Let's give ourselves... a couple of batteries. A couple of solar panels. No big deal. It's fine. Alright, cool. So what we're effectively going to do is leave this on the moon. And we will take off using that engine and go back to Kerbal. Easy. Easy. No big deal whatsoever. Alright. Batteries to help with SAS? Absolutely. Well, that would be if we really had a huge amount of SAS, but we don't. I just do it as a point of habit. Because if I don't and I need something and I put something on there that needs it later on, presents some problems. Okay. Areas to make sure you've got power throughout the mission. No power equals no control. That's very important. Absolutely. Alright. What I might do, grab this. Heat shield. No control means crashing. Absolutely. That is true as well. Alright. How is this real life? Really? There. Cool. Alright, so 860 DeltaV. Ugh. How? 860 DeltaV, 848. Ugh. That displeases me greatly. Okay. Let's pop this on there. And I'm going to add a tiny little bit of extra fuel. Monoprop. Toroidal fuel tank. Let's do this. Is that going to help at all? Does it help? Alright, grab that. Get that cat out. Get that one in there. How does that even work? As I said, is this real life? Come on. There we go. That's better. Bang. Alright, that's plenty of DeltaV. Plenty of DeltaV. Fabulous. Alright, let's get our thrust limited back up here just a little bit. Sorry guys, there we go. That top stage will return me from the moon, that is correct. Flaming Thunder, hello. You are remembered. Sorely. Okay. Alright. Thought process on why I was during at DeltaV. Look, it's... Yeah, the DeltaV map that Root Negatives just put up there, these values are from memory, but the truth is that a lot has changed with the release of 1.0. The atmosphere's changed, the whole model has changed. So it has some rolling impacts that do change the game. They really do change the game. Alright, cool. Excellent. So we're good here. Whew. Is it just me or has it gotten hotter in here? I don't know. I think my wife's put the heater on. Anyway, enough about that. Alright, so this is going to bring us down. This is going to bring us down. That's cool. 924. Plenty enough. Plenty enough. Moon and Mimus is still good. Alright, cool. Lucy, yes, just me. Thanks. Give me a complex. Give me a complex. Alright. All DeltaV map numbers that don't enter an atmo should still be the same. Okay, fair enough. Fair enough. Alright, let's go here. We want body, Kerbal. Atmospheric, because Kerbal has an atmosphere. Let's grab this. And the big thing I would suggest is think smaller before you think larger. Why am I doing it with this sort of tanks? Well, because I've done it before. That's the only reason. We do that, and we have a look at how much DeltaV we've got. Okay. We got about 2,000 in that stage. It's not enough. It's far from enough. We could probably grab that, pop another tank in there, and go like that. Increases it. You gonna throw a transfer stage on this bad boy? Look, I might. It's probably a good idea. Yeah, I think that was probably more the point that I was going for. Alright, so if we take a look at that. 2,073 with those two tanks. So if you think about it, it's about 1,000 a tank. But if we add one more tank, we only get about 500 out of that. 500, 600, something like that. The reason why is because the amount of weight that's now acting on that one tiny little engine, it's too much. It's too much. So it's reducing the efficiency. To further illustrate that point, too, take a look at the thrust to weight. 89, 0.89. Take this out, pop it back, 1.17. Considerable difference. That's a considerable difference. So let's get rid of that. Diminishing returns. Exactly. Diminishing returns. So that would be my transfer stage. 2,000. Alright. It's a lot. It's a huge amount of DeltaV. It really doesn't need to be that much, to be completely honest with you. But Kerbal 007's building along. By all means, my friend. By all means. I consider that a pleasure. So let's do something to help. Because 1.17 thrust away just doesn't really feel like enough. So let's do something else. Let's just go for another couple of tanks. Because if you think about it, it's about 4,500 that you need just to get out of the atmosphere and get into a regular orbit. That's why you'd want transfer stages. Yes, bigger engines to lug the weight. True, yes. However, if you think about it, you're only really adjusting your circular orbit. You need to get out of the atmosphere first. Alright, so you ditch the really, really large stages. And when you get into that orbit, you need to adjust in an efficient way your orbits. Alright? Actually having only this one section here with, say, if I went, okay, bang, this large tank was running through and we didn't have this little lander component, it's going to be a ridiculous amount of work to try and land it. Not necessarily just because of the weight, but because look at it. It's huge. It's just ridiculous. You couldn't land that. So that's where you go for a transfer stage. You just put stages in there. Right? You're getting 1.51 with MechJeb. Do you have this little tank in here? The little toroidal fuel tank? Do you have your lander legs? Are you using an LV909 for your lander stage? Alright. So, we got that. Got a couple of those guys. And let's add in a couple of these Reliants. Alright. So if we put all of these guys, if we have these guys on the outside here, it gives us a thruster weight of 1.16. Not quite enough, so let's put them all together. 1.64, pretty good, really important. 9 kilometers a second for this mission. That sounds about right, yes. That's what we're aiming for. So that gives us much more speed. But our DeltaV doesn't really change. Probably our best option would be to look at some fuel ducts. And the reason why I say some fuel ducts is because even though we engage these here, when these tanks here will feed in to this tank at the same time that they're using these engines. So all three of these engines will run out of these 4 tanks, and then we ditch them. We ditch them. We get rid of them. Gives us the same amount of power, but that, what was it? 2600? 2800 DeltaV? Yeah, no, sorry, maximum of 3228. Actually changes to 37. So we've gained 500 DeltaV. It's not bad. It's not bad. It's pretty good. But we can go even further. Let's grab a couple of these guys. And we go, alright. Let's pop this to here. This is a process known as asparagus staging. It's not a scientific term. Anyone who ever says it's a scientific term, I don't even have words. Just say, stop that, silly person. So what do we get out of that? Bang. Stage 6, which is here when we ditch these tanks, and we've only got the transfer stage, we're already out of orbit. So this is good. This is good. This is what we want to see. So, what's the aggregate number from all of the engines and stages? Well, that's what I'm about to show you right now. This is cheating. This isn't cheating. These are concepts that a lot of people have come across. There's lots of concepts that a lot of people have come across. So, not really, it's totally legit and an easy way of getting the DeltaV you need. Exactly. Alright. You could just put more engines on continuously, or you could add more fuel, or you could do all of that. The reality is, the simpler you make it, the better. So what we're doing here, alright, we've got 1.76 thruster weight here. We've only got 915 DeltaV, but that's not what we're actually getting. This is the first stage, that's the second stage, and that's the third stage. Alright, first stage with these guys running, second stage with those guys running, third stage with that running. Alright. Not going to take us a whole lot to get there. We're at 4.9k with fuel lines. I've got 5.9 in total. I got 5.9 in total with the lander. So, what we can probably do is add a tiny bit more. Tiny bit more fuel. 6. So realistically, what we need is 4,500. 860 to get the moon intercept. So that's 530. No, that's 530, 530, 540. 5,400. We'll say 5,500. Alright? We're not going to make it because 49.55 is where our lander is. Okay. Running all of this by memory is really not doing me very well, is it? I've spent way too long building massive rockets. Massive rockets. Actually, let's get rid of them. Let's go for structural. Yeah, let's go like that. And we'll get a couple of these cats. Now we pop these on at the same time as these. And then we just, yeah. Will that get us over the line? Not quite going to get us over the line. Not quite going to get us over the line. Thumper? What's a thumper going to do? Still not enough. Just build a rocket that can go to Elu. Oh, jeez. Alright. You need more fuel, not thrust. That's true. But I haven't thrust limited anything yet. Alright. I'm a bit concerned about the amount of thrust we're going to get out of these. Let's do that. Let's have a look. 52. SRBs are thrust. Yeah, it's true. Well, alright, fine. Then let's get rid of these. Bring that down. Pop this on. Bang. The outer ring can handle more juice. It absolutely can. Actually, let's ditch that. Let's grab that. No, that doesn't give us enough thrust to weight. Alright, so yeah, it is the outside that needs it. Cool. Alright. Back on track. Back on track. There we go. Look at that. Bit ridiculous. Alright. So we're good. We're in the right spot. We get all them running at the same time. Bang. Bang. Get rid of that. We're ready to land. Cool. I don't mind that. I'm pretty happy with that. Let's get some aerodynamic nose cones on here. We can do that. That's cool. That'll do. Let's bring it down. Ridiculous. Yeah, of course. It's one of my builds. My builds are always ridiculous. Now let's add some space tape. The EAS4 tape connector. Thank you very much, Josh Wu, for giving me my own part. Just give me a part named tape. I'm so happy. Let's do this. Now. There we go. Now, the reason why we're doing that is because it's going to become very unstable. Alright. Now, we don't need a huge amount of these. We really don't. We only need a couple. Because we're not dealing in massive amounts of thrust. Why did that rotate? That's just silly. Stop that. It's silly. Get out of there. Alright. So bang. There we go. Now, we're in about the right spot. Because that's going to stick out the bottom, there's a couple of ways we can deal with that. I think the simplest way is just to go like this. Bring it back to there. Cool. That's about right. That'll do. So, let's just take it to the launch pad, shall we? Cool. I'm feeling pretty comfortable about that now. Alright. Back on track. Now that the theory's out of the way. Now this ridiculous looking craft, it will get us to the moon. That's clipping mode, offset mode. Yes, that's the one. You can clip you can clip components into the craft, or you can just offset their position ever so slightly. Okay. Ready for takeoff. Flaming Thunder's got it right. F5 for safety. Always. T for SAS to turn our SAS on. That'll give us a little more control. Alright. It won't get back though. We'll see. We'll see. If we don't get back, at least we've made it to the moon, and that's a mission in itself. Here we go. 3, 2, 1. Space. I still love that effect. It's so cool. Sorry. Alright. Bring it in. Now, because there is an atmosphere here, we're about 2,000 meters a second short on return. Yeah, I know. I know. We need to start turning. It's a monstrosity. It absolutely is. Now, one thing that you might want to add is some fins. Alright, because if you haven't done this sort of thing before, it becomes very difficult without fins. Yeah, there we go. Rescue missions. Exactly. Root Negative's got the idea correct. It is a very strong Kerbal tradition. Alright. Talon Jazra, just the standard one. Just the moon. M-U-N. We're teaching Alpha Blue how to run missions. Now, that happens if you don't have fins. Okay. So that's not going to be friendly because of the mass towards the top and when that changes. So let's go back to the vehicle assembly. Root Negative, we weren't at the stage point. Weren't there yet. Oh, I thought smashing into celestial objects was the other Kerbal tradition. Crashing and explosions. Let's do that. I'm not even kidding. That's fun. The very first thing I did, right, when I did my very first moon mission, I said, I don't care whether I actually land on the moon. All I care is that I make it. So I crashed. It was great. It was great. Litho braking. Exactly. Exactly. So good. Okay. Did that come through as one? That only come through... How did that only come through as one? You guys would have seen me change that. Seems plenty for a moon run, even more for a Minmus. Yeah, it's close. 4. There we go. Thank you very much. Let's go. Gonzo TW is giving me the host as well. Thanks, Gonzo. It's really appreciated, my friend. It's been a while. Haven't seen you in a while. Alright. F5 for safety. Here we go. Get that up. SAS on. 3, 2, 1, and off we go. Plenty. It's still so cool. Smoky thing goes in, smoky thing comes out. Makes sense. Now we try to bring it up. We're trying to get to around about, say, 2.5 odd before we start turning now to meet the new aerodynamic model. Or actually, technically, we're meant to start the tilt around about 500 to a kilometer into the air. Alright, and we only need slight adjustments, so I'm just tapping the button now. That's all I'm doing. I'm tilting to the right. And the reason why we tilt to the right is because while the planet is turning one way, we're trying to go the other way. Or we're trying to actually turn with the planet, rather. We're trying to turn with the planet so that it makes it a lot easier. What was the pop-up over the fuel line? There was no pop-up over the fuel line. There wasn't any that I saw. Okay, that's one set of tanks. Let it go. Goodbye, tanks. We no longer need you. You served your purpose. Take care now. Bye-bye then. So now we've got 2 tanks. Alright? It's going faster. It's going faster. Take a look. See? It requires less power to move. So what we're going to end up with is a craft happily in orbit. We'll always turn to the right based on the view that you initially have coming out of the hangar. In a matter of speaking, yes, but also on the nav ball. If you take a look at the orientation, we started right at that dot. We're turning to the right. Okay? So let's keep an eye on our Apo apps here. Alright, turning to the right. Yes, the 90 degrees marker on the nav ball. Correct. So if we take a look at our Apo apps, we need to get that to about 80. Saves you about 340 meters per second of DeltaV. Yep. Okay, so 60. Need to get to 80. So we're meant to sit at about 45. Right? We should have been fully at 45 by about 15 kilometers up. Right? But the craft is continuing to turn. That's okay. We've now hit an Apo apps of 80. Right? As you can see here from Kerbal Engineer. It's also shown here. Alright, so you can see that. Not right, but east. That's technically correct, yes. Flaturator's got it right. Alright, do you know where does high orbit start and end, and where does low orbit start and end? Good question. 250,000 meters? Well, low Kerbal orbit is 80. Alright, low Corbin Dallas multipass. Low Kerbal orbit is 80. And that's all you really need to aim for. Alright, as far as I know, all bodies in KSP aim for 90 on takeoff. It's pretty much the best options, yes. Alright. Alright, cool, yeah. In real life, how much would I take to launch and be in orbit? That's a really good question. I don't know the exact science. I'm not that familiar. Big bada boom. Exactly. Now, we're coming up to that AP marker. Alright. I've moved my craft so that it sits on this white line, which is the horizon. And as we're sitting at 80, 82 is our peak. Let's start burning. Engines at full. And we need to watch this periapse go from 500 kilometers below the surface to 80. Okay? Or above. So low Corbin Dallas is 80. Yeah, Corbin Dallas multipass. Corbin Dallas multipass. Multipass. There we go. We've run out of fuel in those, so I'm going to roll the craft real quick and ditch them. Goodbye, tanks. Cool. So this is what's referred to as circularizing your orbit. Okay? So if we tilt up a little bit, it'll make things a little bit more complicated. But as you can see, we're starting to come up. Our periapse is coming up. So as soon as that hits about 80, we can stop. And stop. 77. Yeah, you're about close. So we've rolled the craft. All right. So we're back to the original orientation now. So let's come back. Close enough. Close enough. So that's when you orient 90 degrees and burn as you get close to the apoapse. Exactly. Now, as you can see, here's our apoapse and periapse. Pretty spot on. Makes sense. We have an orbit here. Look up DeltaV budget on Wikipedia for real life info. Ah, good one. Nice one, Flatrated. Okay, so let's have a look. Where's our moon? There's our moon. Now this is the simplest way to do it, and I've seen this explained by Das Valdez multiple times, and I love it to pieces. It is a great way of explaining it. You add a maneuver here, anywhere on the blue ring. You add one anywhere, and see this? You grab the green marker here and pull it until that says 860 or 855 thereabouts. Alright, now as you can see, that'll put us way behind the moon. To catch them, that is our trajectory. That is where we want to go. If we do a burn when we hit here for 855 delta V, it will take us in an orbit that is this shape, right? So what we need to do is grab it and drag it and bring it around. Ah, why did it delete? Hang on. Let's do that again. Because I broke it, that's why. 855 or 856. We grab it and we just drag it around, and eventually, wait, look at that. Orbit's changing. Ta-da! There we go. So that's where the moon will be. Okay? Now, because that would leave us leaving at the apoapse, it's going to cost us a little bit more. Alright? Which is 860. It's a difference of 5. It's no big deal. Okay. So that makes sense. If we have a look, our current stage has 1793 delta V. It's not really an issue. Not going to be a problem. So you just bring it around until you find it. Alright? What mod you use to show your missions on screen? Do you mean the detailed version? The detailed versions that I was looking at before, Frosco? It's called, what was it? Career Plus? I think it was Career Plus. I'm not sure. I installed it earlier tonight. I would have to get back to you on that one. I need to update the mod list now that 1.0 is out and everything's changed. Now, what we need to be aware of, Alpha Blue, if you take a look, this periapse is basically saying that the moon, we will have a periapse when we get there, which is the closest point of 178. So to explain to you why that's important, I'll use Kerbal as the example. Periapsis is the closest point in your orbit to the planet. Apoapsis is your furthest point away. As you can see, 78 kilometers above the ground and 102 kilometers above the ground. Your lowest point and your highest point. So what you really need to do, you grab this, you get your intercept, and if we travel along at this trajectory, we will end up with our closest point to the moon at 178 kilometers. Probably want to be a little closer than that. So let's scroll in and let's fine tune this just a touch. All right, we bring it a little further along. There we go, 14. 14's pretty good. Let's even fine tune it and make it 24. Bring it back out a little bit. So that's good. That means that we can actually get a decent capture without spending too much delta V, because the amount of gravity from the moon will help to maneuver us around. Right? It'll help us a little bit. It's good. It's a really, really good idea. There's a whole other concept called aerobraking, which is when a planet's got an atmosphere, you can use that atmosphere to slow your trajectory quite considerably. That's a whole other ball game. Let's just stick with the gravity side of things first, all right? So now that we've got that, there's two things here. There's two things here. Take a look down here at these two items. Node in T minus 10 minutes and 44 seconds. That means that's how far away I am from this maneuver. This is my craft, and this is where I'm going to be. So it is going to take me 10 minutes and 34 seconds to get around to that maneuver. How long will I have to burn in order to meet this target? We will need to burn for 49 seconds. Right? Root Negative's got the best idea. Play Sandbox for a little bit to understand it, and then, you know, work your way up to career. It's challenging. What's that? You get buttercake. Buttercream. Buttercream! Sure, why not? Let's go with that. Nice one, Maya Deck. Nice one. Well done. GG. So, what we really need to look at as well is what direction are we going to burn? When we get to here, what direction are we going to go that's going to extend that out? And the answer is prograde. Take a look at your map here. Do you see that marker? That's this marker here. We pulled that right out, and that gave us this. So what we're doing is speeding up. Now, prograde means the direction that you're traveling. Retrograde means the opposite direction, so backwards, effectively. If you point retrograde, it is what we were talking about earlier with Soda Shack here, right? This is prograde. This is your prograde vector out here. So if you're pointing this way, you are moving this way. You accelerate more, off you go. All right, you are getting a prograde speed increase. But if you turn it around and you shoot retrograde, your nose is pointing retrograde and you start firing this way, it's going to slow you down for all intents and purposes. But it is a change. If you think about three-dimensional space, this is probably getting way too technical, but three-dimensional space, you can burn upwards, you can burn forwards, you can burn that way. So you can burn in any of these directions. It's a sphere. What you are essentially doing is changing your trajectory whichever way you're pointing. And we just want to accelerate. That's all we want to do right now. Okay? So here we go. Science is a whole other thing that I'm trying to figure out as well. Maximizing science gain and whatnot. Okay. Maximizing the science gain. If you're playing science mode, then that's all your goal is. So stick with that. If you are playing career, you'll need to find a balance because it becomes more difficult. All right. Flaming Thunder, I appreciate that. I am certainly not a qualified teacher. They say that those that can't do, teach. Needless to say, I make science fiction ships. Binks, don't even get started with me. You are not playing Solitaire. You don't need to worry about DeltaV in Solitaire. So, what we're going to do... Root Negative. Take care, man. Thanks for helping to explain the finer points. It is really, really helpful. Take care. Enzo, take care. It's good to see Enzo here as well. All right. So to explain to you what's happening right now is we are pointing in the direction that we're traveling. But if you take a look, let's speed up time just a little bit. Uh-oh. We're still pointing in the same direction, but we need to come back around. And what's this blue marker? That blue marker is technically our maneuver here. Mr. Mango! WTF? Thank you for the follow. Welcome to the Psychos. This maneuver here is this here. This is where we need to point. But as you will see, look at these two getting closer. You're getting closer and closer and closer and closer. Because as you come around, while your ship stays still and you're coming around, it's going to move. Your prograde vector changes. So here we go. Root negative. That'd be really great, man. I appreciate the support. Binks, you're sharing solitaire, really? Come on. Contracts Plus. Contracts Plus. That's the one. Nice one, Frosco. Well done. Okay. What goes around comes around. Let's do this. So 1 minute and 48. It's a 49-second burn. So we need to kind of split the difference. Conceptually, this is the very center of your burn. If you burn 24.5 seconds on that side, 24.5 seconds on that side, you're going to get right in the middle as much as you can. Well done, Insufferable Scotsman. Well done. Nice one. So let's see when we hit. Well, we really want to be pointed at the maneuver, don't we? All right, which is going to be the same. We want to point at the maneuver and go, all right, 24 seconds is when we want to start burning. Take care, Bings. Take care. Ghosty, I'm glad you're finding it interesting. Here we go. 27, 26, 25, 24. Burn, 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 burn. Yoshi Endover, no. Kerbal has 2 moons, and there's several other planets with several other moons. You can go to a lot of them. There's Gas Giant, Jewel. There's even a planet comparable to Pluto, which is Ilu. So let's take a look at what we got here. No, you can't really see that, can you? Because we're in darkness right now. So we're still burning. We're still burning. We just let it burn. That's all we do. That's all we do, and we get ready to kill our engines. As soon as this hits 0, we watch it scale down. As soon as it hits 0, we stop. Here we go. 7 planets total. That's about right. But the moons are sometimes fun too. So stop. Alright. 11.4. Let's fine tune it just a little bit. And there we go. Okay. No, we need to keep going. Watch this. Watch it. There we go. What is this giving us? Oh, we got to keep going. No, that's saying we've gone too far. All right. Well, that's fine. So what do? We point retrograde. Because we need to be going a little bit slower so that we get there just after it's been. So you're doing 24 seconds before just because you're going to split the difference of the 49-second burn. Exactly. Exactly. If I've got a 49-second burn, that's a huge burn. If you're talking about 3 seconds, it doesn't really matter too much. It doesn't matter too much at all. But when you're talking about 49 seconds, that's a huge burn. That's a huge burn. So yeah, it's better. Wayne's been there, my friend. Been there. Alright. So let's slow ourselves up, in a manner of speaking. Alright, cool. So it's just a tiny little burn. And 16 kilometers above the surface. That's about where we're sitting. So let's... 22. There we go. So let's have a look. Our craft here. Look at our fuel level. That's our fuel reserves. What we've got to do now is get to the moon. Guys, I've consumed a huge amount of water this evening, so bear with me. I'm going to duck away and go to the bathroom real quick because I really should do that. It's been nearly 2 hours since I last got up, so I will be back in a couple of moments. let's get out here so that you guys have a little bit of sunlight and a ship to look at. I'm going to duck away very, very briefly. Have myself a few moments to go to the bathroom and whatnot. So let's do that. I'll be back in a couple of minutes, guys. See you shortly. And all you guys following, thank you so much. I'm going to read all your names out as soon as I get back. Just stick around. Alright, ladies and gents, hello. Sorry about that. Alright, where are we? Overly DP VODs this because it's great. I could do that. I could do that. I did give some consideration to that. Alright. Here we go. Talon Jazro, what issues are you having at launch? Earl Grey's not overrated, Warrior. Alright. Okay, Martin GZZZ. Simple question I have for you is, are you stopping all engines when you do it? What kind of decouplers are you using as well? Rev more learning, not enough control authority due to lifting body issues. Warrior, I love Earl Grey. It's really nice. Welcome back, Flaming Thunder. Alright, not enough control authority due to lifting body issues. Perhaps assemble in space? Have you thought about doing that in low curve and orbit? Like actually building it in sections and creating rendezvous to the craft? And building in space. That's often the easier way to do it. I've seen a lot of people actually try to get the whole lifter up there. Hell, I'm one of them. But yeah, it might be easier just to get it put together in space. Probably be a better bet. Alright. No, I'm not, and I'm using stock decouplers. The standard stock decouplers are a little close to the body. They're a little close to the body. So it might not be a good idea to use those stock decouplers. Yeah. Placing the angled nose cones with the basic ones helped. That does help because automatically your aerodynamics are going to create... Well, if you think about it, where's something that is conical around here? I tend to have a lot of stuff lying around. Here we go. Because I'm a pop culture nerd, I have a bottle of True Blood here. Alright? Conical on top. If you have all of your air streaming downwards, right, it is separating along these sides. But if you put it on an angle and you have a straight edge here, it's going to come down the straight edge, but it's also going to come down at an angle, which will create two areas of force. The force will be coming downwards and it will be coming against it. So it will actually push them inwards. Right? That's an issue. That's a big problem. You need to make sure that you've got them straight up so that it is evenly distributed downwards so that it just shoots downwards. If you are experiencing difficulty with it and you'd like them to come apart at the top, put the angled ones on, but the other way. Put them outwards and it should separate them out that way. That is a correct aerodynamic model. I don't know whether that applies to the changes that have been made, but that's the theory. No problems, Martin. No problems at all. Separatrons are also a solution, yes, because they do create force. Be very careful with them though, because you can actually fire them directly into other tanks and cause them to explode. So be careful with your orientation. Let's continue on. Let's keep moving. Let's have a look. This is how far we need to go. So let's keep going. Now, we are currently in Kerbin's gravity well, which extends to about here-ish. Right? But within Kerbin's gravity well, we have the moon's own gravity well. And that is what this yellow marker is. That is the sphere of influence. Myodeck's pretty much what I think. Design, yes, it is a game, but it is mostly realistic. It is based on solid Newtonian physics. DevMelon, we are currently teaching Alpha Blue how to land on the moon. How to actually fly a craft in Kerbal Space Program. So out of 10, I would say 7. Alright, because everything is pretty much accurate, but there are changes that are made that do change the reality, the realism factor. Based on the aerodynamic model that came out with 1.0, I would have said it was closer to 9. But they've made some changes since then, so I would say it's less accurate now. Personal opinion, but I don't know. I don't know. Need to learn good. Need to learn goodly. So I've accelerated time a little bit. You do that with your brackets, your greater than and less than symbols. But as you can see, as we're coming along here, the moon is coming up along as well. And that's pretty much the path we're going to take around the moon. But look what happens when the sphere of influence changes. Thanks, Talon. Thank you very much. So watch this. Watch how it displays. Here we go. Sphere of influence. We are now hitting the moon's sphere of influence. And time warp slows us down. Bang. As you can see, the moon will hit to about here by the time we get to the periapse. But that is how it feels inside the moon's sphere of influence. Don't be intimidated by that. It's not a big deal. So we're going to come around the dark side of the moon here. But we really need to start a maneuver at the periapse, because what are we going to do? We got to slow down. At this stage, we're going too fast around the moon that we're just going to slingshot out the other side. And that'll probably put us into a solar orbit. See that purple line? It's saying we've got so much power in there that we're going to go out into a solar orbit. We would be orbiting the sun because of the sun's sphere of influence, which comes out to here. Alright? So, let's come back in. And we want to add the maneuver at the periapse. Now, as I said before, if we fire prograde, we're going to get faster. If we fire retrograde, we're going to get slower. So what we need to do is try and slow ourselves down so that the orbit comes around and creates a full circle. That's the theory. So watch this. Our yellow line is our projected trajectory at our current speed. So we slow it down, and look at it coming inwards. It's still solar at this stage, but have a look. Look at what's happening here. This is turning. So let's bring it right the way in, slow ourselves up, and bang. There we go. So we're performing a maneuver that keeps us within the moon's sphere of influence. And we just keep going until we get that mostly circular. Now, if we remember, the periapse was 22.5 kilometers. So we want that apoapse to be about 22.5 kilometers. That's where we want it to be. So we take a look. 313. So let's keep going. Allergic. Allergic? Is that what it is? Allergic. Hey. Hey. Alright. Let's say great gig in the sky on the dark side of the moon. Yeah, Warrior. Absolutely. Don't even start with me on that. Dark side of the moon. What do you give RSS if you give stock a 7? RSS, I haven't played around with too much, but the reality factor of it, look, it brings it closer to the reality of our solar system, not necessarily the reality of the physics built into the game. That's a constant. The physics built into the game is exactly the same. Forgot about my science lab on the station. There was 400 science sitting there. Wow. My deck, that's crazy. That is really crazy. Alright. 156 kilometers up. We need to keep coming in because we need it to be about 24. 64. 42. So let's put it a little closer. 25. 20. Let's do this. 22. 23. Alright. 21. 22. Now we're just making some tiny little adjustments to adjust where in that rotation we're going to go. So we're not going to go completely retrograde. We're making some tiny little adjustments. It's night now in Australia. Yes, it's 2 a.m. It's 2 a.m. It's a nice late night for me. So let's point towards our maneuver. Now, if we take a look at where our maneuver should be, watch this. See the blue arrow? We're rotating our craft. Look at our craft rotating, like that. Alright. It's between that marker and that marker. Whoop, let's freeze it for a sec to bring it back. What will happen, as we saw with Kerbal, as we move, this will travel closer to retrograde as we get closer to this point. Alright? So that's where we need to line up. That's what will happen. So if we sit on the maneuver here, we'll speed it up just a bit. Look at it moving. On the nav ball. Moving. As you can see, getting much closer. Alright. But we're right up to the point where we nearly need to make a maneuver. Alright. 28 seconds is our burn. 299 DeltaV. We got 928. We got plenty of DeltaV. There's no issue with DeltaV. Flaturated. This week it is at 196. It's still in the top 200. That's crazy. It's a fantastic album, don't get me wrong. I absolutely love Pink Floyd's Dark Side of the Moon. So, look, 3 minutes and 20 seconds. So, 18. So we need to be firing 14 seconds before we hit that node. So when this says 14 seconds, this T minus, that's when we start our burn. And we just go engines at full, firing towards our target, which will be pretty much bang on retrograde here. So let's speed up time just a little bit. Alright. Speeding things up. There we go. Okay. So 31 seconds, 29. We need 14. 14 is what we are aiming for. Here we go. 21, 20, 19, 18, 17, 16, 15, 14. And we keep going, watching that slide down. And then we stop as soon as it gets to the bottom. And stop. Okay. So we're about right. Let's adjust. Just slightly. Okay. So it's close enough. Is really deep even 10 minutes in the future? There he is! Kerbal 007. There he is. You legend. Well done. Well done. That's exactly what is going to happen here. That is exactly what's going to happen. I didn't give shoutouts a couple of minutes ago. Or, geez, 25 minutes ago. Wow. Fuzzlecat, Yoshi Endover, Alpha Blue, and Mal Dennis. Thank you for the follows, guys. Completely forgot to call you guys out. That's really mean of me. Alright. Time travel is not a lie. As we sit here, look at this. We have an orbit. It's not completely horizontal, but moon. So what we should probably do, we should speed up time a little bit. Now I've focused on the moon, so we can see our little dude moving around here. This is cool. Right? Now we can see that it's tidally locked, can't we? So realistically, for us to burn retrograde when we leave, we need to go this way. Alright? So it's probably best that we sit about here somewhere on the map. That'll be the best way to do it. Alright. Target is for PC or for AC? Hang on, what do you mean? What do you mean? Alright, let's get over to our craft. Now, we're in F5 for safety here. Landing point, it does make a big difference, depending on how much fuel you want to spend. We don't want to spend a whole lot of fuel, so I'm going to go back to the Space Center real quick, because I want to bring this around. Where it's sitting in regards to the orbit, where the moon is sitting in regards to the orbit, is too far around the wrong side. So let's bring this around so that we got it about here. Cooling for PC or cooling for the air conditioning? Allergic. 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 I like it. Okay, I get it now. It's technically for both. For the simple purpose that it actually gets really, really hot in the studio. And if I do streams that are like 8 hours, and tonight's going to end up being about 8 hours, I end up feeling rather uncomfortable and drinking lots of water and having to take lots of breaks, and it's just really uncomfortable. So that's the whole reason. It's for cooling for both. So at the moment, our craft is orbiting without an issue. See, going around. Whoop, 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 whoop. Right? The reason why we do that is because the moon is what's referred to as tidally locked. Alright? Same as our own moon. Our own moon is tidally locked as well. It is always facing the same way. Egg1E1 Gaming, thank you very much for the follow. I really appreciate it. Welcome to the Psychos. So if we take a look, this is always facing the same way. Always facing the same way. This will always face towards Kerbal. It's just what faces the sun that changes. Alright? So as you can see, this is our orbit. Our orbit hasn't changed. Alright? Important things to know. So, when we go back to the Space Center, we'll take it a little bit further. Let's go here. We want to bring it around a little further. So let's speed things up. Whoop, 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 whoop. Alright, now we're around the back. Let's fly. Let's take a look. Take a look here. Reviving chat. Flaming Thunder. Doing the revival. Do we still have Alpha Blue? Is Alpha Blue still here? Yeah. Okay, yep, there we go. He is. There we go. Be really great if I could read. So let's come around. We take a look. So let's say our periaps here. Now we've got to think about where we're going to maneuver down. Right? I'm going to land right about here in this crater. I'm going to land about here. So let's F5 real quick. Let's add a maneuver just to the periaps. It doesn't have to be at the periaps. It can be anywhere. It all really depends where you want to land. So let's take a look. If we do that, we're going to come in that way. So we need to bring this down a bit. Right? That'll bring us to about there. Cool? So we want our landing zone to be right here. But I'm going to say overshoot it. Mark it so that it's going to be overshot a bit. Alright? There is a reason for that. There is a very strong reason for that, and you will see that in a moment. Let's point towards a maneuver, shall we? Let's get pointing towards that maneuver. Here we go. Whoop. It's going to move way past. Boom. Okay. Cool. So again, 4 minutes and 37 seconds down here. Estimated burn has an NA because it's 49 meters a second of DeltaV. We don't even need it. I know you guys can't see it all that well, but let's bring this around. Is it possible to leave the solar system in this game? Yes, it is. It's not going to serve you any good because there's nothing out there. Nothing out there. Cheekid, I'm actually teaching Alpha Blue how to perform these maneuvers and get to the moon and back. So let's take a look. We don't need this stage anymore. This is our transfer stage. We only need our lander stage. So let's stage and say goodbye. Goodbye. Boom. Gone. Alright. So we got less weight. We're going to need less DeltaV to make those maneuvers. Alright. 343, that's well enough to get off the moon. Kerbal 007, I'm not even going to use the 909. I'm going to use the separation stage because if you think about the moon missions, you know, Neil Armstrong, Buzz Aldrin, those guys, you know, the old Apollo missions. When man landed on the moon, they left the actual lander body there. They left the lander there. So let's run on kind of a theory like that. And that's how you make space debris. Allergic, you're exactly right. That's now space debris. It's junk and it's staying there. Could you use the DeltaV in that stage to break? Doonton, look, we got so much DeltaV right now, we're going to be fine. Alright, it's just to make a point that we don't need it anymore. Alright. Let's get ourselves ready to do the burn. 9 seconds, 8 seconds, 7, 5, 4, 3. Let's go. Here we go. And stop. There we go. So I've increased the amount of DeltaV, increased the amount of thrust in there. And you can say, Cheekid! Thank you very much for the follow. Welcome to the Psychos. So there we go. It's about where we're going to go. They left a ton of stuff on the moon. Yeah, they really did. They really did. Find our remains on the moon, absolutely. Downtown. Not Doonton. Downtown. Downtown. Let's go with that. Let's go with that. All right. So we gotta wait for this to happen. Let's F5 for safety. Let's point ourselves retrograde. Now there's a reason why we do that. It's so that we can slow down. All right. 15, 16, 17. That sounds about right. 2 pairs of boots, a sculpture, a feather, a human waste, and a ton of other stuff. That sounds about right. Sounds about right. We did leave a lot of stuff behind. It's very true. All right. Let's come along this way. Let's speed up time. Speed it up a little more. All right. Flatulated, very true. Golf on the moon. Now we can see that we're coming in sort of horizontal here. How do you land straight down when you're going horizontal? It's probably the big question. Flaming Thunder, we're about to land. We're about to land. Here comes the tricky part, not making a crater. My first landing attempts were pretty much that, craters. There is actually a video on this channel of me swearing and getting overly joyed, just ecstatic at being able to do this for the first time. After having played it for so long, yeah, it was a very, very happy moment. Alright. So we can see what we're doing here. Now, we do need to slow ourselves down. We do need to come in to brake. Let's put our landing gear down very quickly. But we need to slow down before we actually become part of this crater. Let's look at how high we are off the ground. Realistically, surface. Alright, where are we surface-wise? Horizontal speed, quite a lot. Altitude, 6 kilometers up. Alright, well. Let's take a look about. This is going to be a bit rough. Where we're coming down. There's going to be a bit of a rough patch. Bit of rough terrain. Doesn't matter. We can slow up quite a bit, actually. Well, rest in peace. Yeah. So let's do it. How much DeltaV have we got? 800. No big deal. We can make it. Moon. Absolutely, this is the moon. I'm not going to F5. I F5 just before. Because if this is going to turn out to be too difficult, then I will revert and use a flatter landing area. So here we go. Let's burn this way. It's not the most efficient way to burn. That's no moon. Yeah. Well done. So we can burn retrograde. It's not the most efficient way to burn, but it can be the most effective. Let's put our thrust upwards here. So, alright, I've left this way too long. I've left this way too long. I did. So, alright, rest in pepperoni. No. Alright. Cool. Sidonian Monk and I Love Play. Thank you for the follows, guys. Really appreciated. So let's do this. So we can come in further. Alright, so this will do. Let's put our thrust back up. Give us plenty of thrust. Gear down. And let's just burn like crazy. Alright. Burn like that. There we go. Burning retrograde. This is burning almost horizontal. The reason why we're doing that is because we're killing what's referred to as our horizontal momentum. Right, our horizontal speed here. Because we have speed in a horizontal manner. Now, as you can see, we're slowing down, but we're still coming downwards. We're still coming downwards. We're still coming towards Kerbal. And as you can see, our retrograde marker has moved up here. Alright, now we are pointing almost practically upwards. Almost completely upwards. Alright, now we still need to slow up. So let's keep going. Need to slow up quite considerably. Here we go. Orbital velocity. You could call it that. A lot of people call it horizontal velocity as well because it's along the horizon. Here we go. Coming down. Look at these massive craters over here. Now remember, you can F5 at any point. Which I'm doing.
The outside is frightful, but the fire is so delightful. And sense no place to go. Make it so. Make it so. Make it so.
Bias! Bias! $50.95. You've taken me over the limit. Thank you so much. That's amazing. You legend. And in the middle of my backswing, if anyone picks that reference, you will all be legends. Bias, you are an absolute legend. Thank you so much. You are way too generous. Way too generous for me. I do not deserve it. I am not worthy. So I can pretty much remove the interface here. I am not worthy. This is my late night teaching session. Bias. Thank you. Thank you so much. First goes, no Star Trek jumper tonight. No. Too warm in here. Lucy! I'm glad someone got it. And we just keep burning slowly. Bang. There we go. And we're down. We're down. Hooray! Button to remove the interface is F2. Good to see you, First Ghost. Bias. Thank you. Can you fly into the sun? Yes, you can. Yes, you absolutely can. Too warm in here won't be a good enough excuse soon. That's true, Tank. That's true. So we're down. We're on the ground.
Oh, the weather outside is frightful, but the fire is so delightful. And since we've no place to go, make it so. Make it so. Make it so.
Kerbal 007, thank you for being so accommodating. It is my pleasure. It is absolutely my pleasure. Thank you so much. Fly into the sun. I could fly into the sun quite easily from here, really. We could. I'm not going to. I'm going home. We're going home. Can't handle the OCD. The OCD, no. So what we can do from here Bob! Let's go, buddy. Off we go. Space to let go. Boof. 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 He's down the ground. He's hanging out. There we go. And let's plant ourselves a flag, shall we? There we go. Alright. For Alpha Blue, you can do it, buddy. You can do it. It's alright. It's not too tough. Jump around. Jump around. Jump around. There we go. Poof. That's probably how I'd end up. Yay! Poof. Bob. Bob, you alright? You alright, Bob? Can you get up? I'm fine, guy. He's pretty happy. He's pretty happy. There we go. Well, Bias, I appreciate everything you are. All of the support, and that is amazing. For myself and everyone else that you do support. Because I know you do. So he's kind of happy right now. He's spinning around. He also has a jump pack. Up we go. Look at his little EVA pack. So cool. And there are a couple of Easter eggs on the moon as well that I'm not going to show you tonight, but you will be able to find them yourself. All comes down to where you land. So let's head over here. Let's jump back into the ship, shall we? Alright. Up we go. Let's get over here. Let's grab on. Oh, climb. Come on, Bob. What are you doing? You can climb the flagpole now. That is true. Grab. Board. Cool. Now, look at how much fuel we've got. About 30 meters a second at Delta V. That's not going to get us home. So let's shut down our engine. That's just with this build. It's just with this build. This is the way that we're doing it with this build. Now, I'm already noticing an issue. If we don't have those in the same stage, this won't work. So, now that we've got that engine shut down, we're not going to go anywhere. But where do we need to go? It's a moo cat, dude. Come on. I gotta purge you again, man. It's funny, but you take it too far. Alright. So F5. It's funny, don't get me wrong. Alright. So where are we now? We're facing Kerbal. This is kind of alright. We're to go that way. Don't spam the Kappas. But if we stay here, we're not going to get around to here. So let's have a look. And it looks like the moon is spinning around. It really does. Because it's spinning around Kerbal. But it's tidally locked. You see? Not going to make any difference, is it? Not really going to help us. So I'm not going to give you guys a nighttime launch. We're going to do this during the day. Let's bring it back around. Alright. All of the cappers, you guys, settle down. That's alright, I just time. It's completely fine. So, alright. Tidally locked. It's a bit of an issue. So, what do we do? What do we do? Well, we got to try and work out how we're going to get home. Let's have 5. Let's take a look. Not offline. Strange. Strange. Interesting. Okay, cool. Alright. Fine. Stream wasn't there for a second. Weird. Excellent. Okay, cool. Cool. Wonderful. Alright. Thanks, guys. Okay. So what are we going to do? We're going to take off and we're going to go shooting for home. How do we do that? Take a look. Except everyone's badge has disappeared. Yeah, that's because your chat is reloading. That's okay. So as we can see, this is an orbit. If you can imagine the moon is a ship. Remember what we were talking about with Soda Shack? With the prograde and the retrograde? Prograde's this way, retrograde's this way. Same as what you're seeing on the screen here. This is the moon's prograde, and this is its retrograde. So in order to get back to Kerbal, the best way is to get into Kerbal's sphere of influence. Simplest way to do that, point retrograde. Start going retrograde. So when we get back to the craft here, let's have a look. That orange line, if I recall correctly, is north? No, it's south. That's south. So that's north, north, east, south, west. So if we take a look, north, south, east, west. So where are we got to burn? We got to burn east. To go retrograde, we got to burn east. So we're burning along this line here on the nav ball. Now, it might take a little bit of practice for me to do because I don't know what orientation I'm currently facing. Well, currently, I am facing this way. So I am probably pointing that way. If I go right, it'll take me along this line. So I need to go right and down a little bit. So let's see whether we can do it. F5 for safety. 3, 2, 1. Off we go. Here we go. So we get a little bit off the ground. A little bit off the ground, so the gravity doesn't destroy us. What happens to the compass in space? Well, it's the compass associated with this particular body. Isn't it? Hang on. No, I'm going the other way. I'm going the wrong way. It is the other way. Alright. I don't understand why retrograde burn is more efficient. Because, Troful, it makes it easier to get into Kerbal's sphere of influence. That's where the difference is. You're not trying to get out of the moon's sphere of influence, you're trying to get into Kerbal's. And that makes it a lot easier to do that. City Fan, hello. Alright, here we go. So it's this way. This is where we need to go. So it depends on what you're orbiting. Yeah, exactly. Exactly.